Chapter 1, Overview of Wireless Standard. In this chapter, you will learn about the following. Let's start with history of wireless LAN. It started in the 19th century where the inventors did research on electrical magnetic radio frequency, also known as RF. First used by United States during World War II, around 1940s. In 1970, University of Hawaii developed AlohaNet to communicate between the islands. For additional information, spread spectrum patented in 1942 but not implemented until 1962. In 1990s, 900 MHz low-speed commercial networks were developed. Initially deployed in warehousing and manufacturing environments such as the usage of wireless barcode scanner. In 1991, IEEE began discussing wireless LAN standardization. Finally, in 1997, IEEE 802.11 was ratified. In 1999, IEEE 802.11b was ratified. In the same year, they introduced 11 megabit per second transmission speed. Faster data rate and price decreases ignited sales of wireless home networking router in home and small office marketplace. That's all for history of wireless LAN. The rest is history. Standard organizations. There are many standard organization and regulatory bodies that help govern indirect wireless technologies. These are the standard organizations that I will briefly explain. I start with FCC. FCC and agencies in other countries typically regulate two categories of wireless communication, which are licensed spectrum and unlicensed spectrum. Licensed spectrum is not free, where they need to go the application procedures before they can install the wireless system. Unlicensed spectrum is free of charge. But unlicensed frequency bandwidth often very crowded. So it may cause interference. That is the drawback for unlicensed spectrum. Both licensed and unlicensed spectrum typically organize in the following 5 areas. Number 1, frequency. Followed by bandwidth, maximum IR, maximum EIRP and use. FCC divided into 50 title. And titles are divided into parts. You can see here that Title 47 and Part 15 relevant to wireless technologies. Next, ITU-R. The main tasks are to maintain database of worldwide frequency assignments, and also coordinate spectrum management through 5 administrative regions. These are the 5 administrative regions. In addition to the 5 administrative regions, the ITU-R defined 3 radio regulatory regions that are defined geographically. Next is IEEE, best known for LAN standard. IEEE 802.11 project is for wireless LAN. You can read this slide later. I try to make it simple. The IEEE 802 represents the project. 11 represents the working group. The alphabet at the back represents the correction and amendment. IETF, their goal to make the internet work better. IETF is part of Internet Society. You can see here that IETF resides below the Internet Engineering Steering Group. Wi-Fi Alliance. Founded in 1999 as Wireless Ethernet Compatibility Alliance, and changed its name to Wi-Fi Alliance in 2002. The main task is to provide hardware certification testing, and also devoted to promoting the growth of wireless LAN. This is the familiar brand label you can see on most wireless devices. This is the example of Wi-Fi interoperability certification. You may go to the website for more details. Wi-Fi certified program offered. And lastly, ISO, responsible for the creation of OSI model. The model developed in the late 1970s. So, these are the 7 layers of the OSI model. Revision for network architecture. Core layer performs high-speed backbone and high-speed switching. Distribution layer provides medium travel speed and distribute the traffic within the city or metropolitan area. Last one. Access layer of the network is responsible for slower delivery of the traffic directly to end user or end node. And this is typically where 802.11 operates. Communications fundamentals. Amplitude is the height, force, or power of the wave. I draw another wave to show the low amplitude wave. Next, wavelength. Wavelength is the distance between symmetry points on back-to-back waves, typically measured from peak to peak. As example here, this is peak A, and this is peak B. The distance between peak A and peak B is wavelength. Frequency. Number of waves generated per second, where one wave equal to 1 oscillation. Frequency measured in hertz. Hertz equal to 1 oscillation per second. Example, 2.4 GHz equal to 2.4 billion oscillation per second. This figure shows the comparison between low, medium and high frequency waves. This figure shows the frequency for 4 Hz and 14 Hz. Phase is relationship between 2 waves with the same frequency, measured in degree, where one wavelength equal to 360 degrees. You can refer this to measure. 2 types of phase difference: constructive interference and destructive interference. Carrier signal. Radio frequency signal can represent data by fluctuating or altering its radio frequency properties. Properties that can be altered are amplitude, frequency and phase. Keying method is method of manipulating a signal to represent multiple pieces of data. The keying methods are also referred to as modulation techniques. There are 3 types of keying method: amplitude shift keying, frequency shift keying, and phase shift keying. 2 techniques can be used to represent data: current state and state transition. I'll skip this. This is an example how amplitude shift keying looks like by using current state technique. You can see the difference when the value is 0 and 1. This is an example how frequency shift keying looks like by using current state technique. Look at the difference when the value is 0 and 1. Lastly, phase shift keying using state transition technique. You need to identify the no phase change occurred and phase change occurred in order to draw the waves. You may refer to my YouTube channel on how to draw the keying method. The figure shows the keying method comparison for amplitude shift keying, frequency shift keying and phase shift keying. Looking back what you have learned for Chapter 1. End of chapter. Thank you for watching and listening.